Hey YouTube, it's AI Enigma here. So this is our fifth session in Road to Cat Lrdi series. As usual, I will provide the PDF of the session in the comment section below, so you can try this at yourself. And after that, you should watch this video. And so let's get cracking. So this is the fifth session. So we have four friends: Joni, Moni, Tony, and Sony. Have 12 vocabulary cards with them, and each vocabulary card has a number printed on it from 1 to 12, which is known as the value of that card. And no two cards has the same number printed on it, which means we have four friends. We have Joni, Moni, Tony, and Sony, and they have 12 cards with them. Okay, they are 12 distinct cards because each card is unique. Then what occurs on day one? The four friends distribute these 12 cards equally among themselves. That is, each friend has 3 cards with himself. Okay, so which means on day one we have Joni, Moni, Tony, and Sony. So they distribute 3 cards with each other, so that each friend has 3 cards with them on day one. Now in the beginning of day 2, each of them give exactly 1 card to each of the other 3 friends, and they repeat the same process in the beginning of day 3 as well. So what occurs on day 2 and day 3? On day 2, Joni will give one of his card to Moni, one of his cards to Tony, and one of his card to Sony, which means he will have no cards left. But in the same process, after giving out, Moni will give 1 cards to him, Tony would give 1 card to him, and Sony would give 1 card to him. So that in the process, he would give a set of 3 different cards. For example, if he has 1, 2, 3 on day 1, so on day 2, he would get like any of the other cards. It would not be 1, 2, 3, because 1, 2, 3 would be distributed in any manner. It can be Moni would get 1, or like Tony can get 1, or Sony can get 1 in some order. Similar thing occurs on day 3 as well. So that in day 3 he will distribute at 4, 5, 6 to other friends, and he will get 3 unique cards with him. Now one of the things is different that you have to remember, that like this occurs. But on question number 3, it states, like, we have one question that can come whether he can get these cards again or not. But it's been mentioned in the third point that in the beginning of day 4, they reshuffle the cards among themselves in such a way that each of them get a set of 3 different cards from ones they had in the past 3 days. So what occurs in day 4, that he reshuffles the cards after that's been done here. They reshuffle the card in such a way that they get a set of card which is unique on day 1, day 2, and day 3, which means if like if Joni has gotten 1, 2, 3 on day 1, so he can't get 1, 2, 3 here, and it can't get 4, 5, 6 here. And on day 3, I don't know what card he has gotten on day 3, but he can't get on day 3 as well, which means on day 4 the value of the cards would be unique. We are still not sure of day 3, which is being clarified in day 4. No friends get any of the cards having the same value for 2 or more times in the span of these 4 days. Okay, which means like everyone would get a unique card value. It would not be like that on day 1, if Joni got 1, 2, 3, on day 2 he got 4, 5, 6, on day 3 he cannot get 1, 2, 3 or 4, 5, 6. So he has to get unique value. Let's suppose he got 10, 11, 12. So on day 4 he has to get 7, 8, and 9. Okay, and that is true for every friend as well. So the first conclusion that you have to make, that every friend would get the value from 1 to 12. Okay, so that is the first conclusion that we are making, that everyone will get the value from 1 to 12. Okay, so that is like completely fine. Now we are given the diagram shows below gives the sum of the values of the card with each of the Joni, Tony, and Sony at the end of day 2, day 3, and day 4, which means we have been given the cumulative sum of the value of the cards that being possessed by Joni on day 2, Tony on day 2, and Sony on day 3. We are not giving the value of Moni. We have not given the value of Moni, and day 2, day 3, and day 4 has been given. So what I've done, I have quickly made a 4x4 table illustrating day 1, day 2, day 3, and day 4, and I've written the values in the blocks below. Now what I will do starting from this set, so let's go with first thing is that we have been made sure that Joni will get the values of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, and 12 in any way. I don't know in what order, but he will get the value from 1 to 12. Moni would also get the value from 1 to 12. Tony would also get the value from 1 to 12, and Sony would also get the value from 1 to 12. Similarly, on any day, only 12 cards are being distributed, that is 1 to 12, which means in horizontal as well as vertical, the value would be the summation of the cards from 1 to 12. That becomes a 78. So the value would be 78 here and 78 here. That is the first logical conclusion that you have to draw. Based on that, by subtracting, you can figure out every value. Let's say on day 2, if I have to calculate the value of Moni, so On day 2, the sum right now is 21 and 19. That makes 30 and 40. 40 and that is 58. So 78 minus 58, that is 20. So that's a beefy 20. On day 3, we have 25 and 11. That's 36. 36 and 7 is 43 and 53. 53. So 78 minus 53, that gives me a value of 25. 78 minus 53, isn't it? 78 minus 53, 835. So yes, 25 is the answer. Then we have on day 4, 26 and 24. That makes a value of 50 and 10, 60. So 60 is done. So this value has to be an 18. And by the same logic, I will calculate the value for day 1. So let's calculate on this value. So this is 21 and 25 and 26. That's 60. 60 and 66 is 5 and 71, 72. So this becomes a value of 6. Then for this, we have 20, 40 and 50. So then we have 58 and 5. That would be 63. So 63. So 78 minus 63. So that would be a 25, isn't it? Or I'm missing something. 20, 25 and 18. 8 and 5 and 13 is 3. 2, 4, 5, 6. Yes, that will be 63. So if we calculate 63, oh no, this value will be 15, not 25. Okay. Then we have on Tony, we have 19 and 11. That becomes a 30, 30 and 24. That's 54. So 78 minus 54, that would be a beefy 24. So that would be the value is 24. And lastly, we have 18 and 17. That becomes a value as 18 and 7 is 25 and 35 and 45. So 45 we have done. So this value becomes a 33. If we subtract 45 from 70, that becomes a 33. Now, immediately I will look at the highest values and the lowest values, and I'm going to switch the color pen, like for easier notation. So the only way possible for 3 numbers to make 6 is 1, 2, and 3. And similarly, look at the other extreme, that's the highest value. The only way possible for 33 to be by 3 numbers, that's 10, 11, and 12. That is the only combination possible by which if we can provide the value 33 without repeating any number. So that's 10, 11, and 12. Immediately look at the next 3 values. That is 7, 8, and 9. 7, 8, and 9 is 7 and 8 and 9 is 17, 17 and 24. So the only way 24 is being, made by 3 numbers is 7, 8, and 9. And 15 is 3, 4, and 5. No, 4, 5, 6. Because the number can't be repeated. So this value has to be 4, this value has to be 5, and this value has to be 6. So that makes it 15. Okay, so that's pretty good. Now after we have to transfer one card to other friend. Now what I will do, as I will make sure that ensure that 3, if I verify that 3 Joni has given some card to him, I will just put a circle here for easier notation. So I will switch the color right now to, let's go with purple. So always when solving this kind of problem, always go for maximum first. Now we know for sure that 12 cannot come here because 12 is already Sony already has 12, so he can't give 12 to himself. So either 12 can go here. So if 12 goes here, okay, so there has to be 3 spots. So if 12 goes here, so we have to make 7 from these 2 numbers, because one card will move from Sony, one card will move from Tony, and one card will move from Moni, and one card from in this manner 19 would be formed with 3 numbers. So if we put, let's say 12 here, if we put 12 here, so we have to make 7 from these 2 numbers. 7 is possible, 4 or 3 possible, 6 and 1 possible. So 12 can be here. There is no problem here. Can 12 be here? If we put 12 here, then we have to make 8 from 2 numbers. So 7 and 1 can make 8. So that is possible, definitely. Because let's say if I put 20 here, so I have to put 8 from these 2 numbers. And these 2 numbers have to be supplied from this. So either that can be 7 and 1, this 7 and this one, or so that is the only possible, possibility for making an 8. So 12 can actually be placed there as well. Okay, so 12 is also a possibility. If I put 12 here, so I have to make 10 from 2 numbers. And those 2 numbers are these 2. So can I make a 10? No, 10 is not possible. So definitely one thing I am confirmed that 12 is not coming here. Because if I put 12 here, no, wait a minute. If I put 12 here, then I have to make 19. No, 9. If I put 12 here, then I have to make 9 from 2 number. And 9 has to be formed with these 2 number, and there is no way I am going to form 9. So 12 cannot come here. That is one possible solution that we have formed. Now let's look at 11 first. Can 11 come here? If 11 has been come here, then we have to form 8 from 2 numbers, and this is the contender. So I can form 8 from 6 to 8. Add 5 from 3 is also possible, so 11 can come here. Definitely 2 possibilities are there. Can 11 come here? Then we have to form 9 from 2 numbers. If 12, if 11 is here, then which means we have to form 9 from 2 numbers. and 9 is can be only formed by 7 by 2. So 11 can possible, 11 is definitely possible here. But can I put 11 here? That's the thing that's been on my radar. Can I put 11 here? If I put 11 here, so I have to make 10 from two numbers. If I put 11 here and 10 from two numbers, so because 11 is done from here, we have to put 10 from these two numbers, and there is no way that I can form 10 from here. So 11 is not going to come here and 12 is not going to come here. That's the result that we have formed, because if we put 12 here, then I have to put you can say 9 from two numbers, and these two numbers are this, and there is no way we are forming a 9. So 12 and 11 both cannot come here, which means the only sum that's being going to come here, that's 10. So 10 is fixed. Since 10 is fixed, so we have to form like 11 from two numbers. So 10 is fixed, so I will put a circle from here. So I have to put 11 from, I have to form 11 from two numbers, from like Moni and Tony. The only way possible for forming an 11 is 4 and 7. That is the only way possible. We have to take 4 from here and 7 from here. That's the only way to form an 11. So this is done. Now again, we will look at the highest most possibility value, that's 12. Can 12 come here? If 12 comes here, let's say if 12 comes here, so we have to form 8 from two numbers. So is there any way that we can form 8 from like here and here? No, there is no way around, because like the maximum value, the minimum value that we can get from Tony is 8 itself, and that will make 20 from two numbers, so that's not possible. So definitely we will say 12 cannot come in here, so 12 has to come here. That's the only spot left for 12. And since 12 is also done and 11 has to come, 11 cannot come here itself, so 11 has to come here. So these are the maximum values that's been already completed. Now we have to form 7 from two numbers on Tony. As you visualize that, we have to form 7 from two numbers. Now these 7 has to be from these. It can be 6 1 or it can be 5 2. So we are not so sure what to do right now, so let's skip it. Let's go with this 20. We have to form 20, already 11 has been done, so we have to form 9. 9 has to be from two numbers, and if you visualize it clearly, the only way to form a 9 is 8 and 1. That is the only way to form a 9, because if you put 9 here, so 20 is formed by two number itself. So this value has to be a 1 and this value has to be an 8. So this value becomes a 1 and this value becomes an 8. And similarly, if you look closely, so this 9 cannot come here, so this value has to go there. So 9 becomes on these three spots, 9 is here. So 9 is already done. Okay. Now let's look at this. We have to form 7 from two numbers from the top right corner. So it can be 6 and 3 cannot form a 7, 6 and 2 cannot form a 7. The only way to form a 7 is 2 and 5. So this value becomes a 2 or 5. So this value 2 and 5. And for verifying, we will see that 6 and 3 forms a 9. So this is 3 and 6. So this is done. So we have done with day 2. And we will apply the same logic again on day 3 as well. Always go for maximum value because it's readily possible. 12 cannot come here because 12 already is here. You can say, because the same card cannot be repeated. So we have 3 cards in which 12 cannot come on to 17. 12 cannot come here as well because the minimum sum is 11 and you can't put 12 again because 12 is already being possessed by, like 12 already has come on day 2. So 12 is either here or here. And because they are numerically the same, 25 and 12, that's 13. So I'm not so sure whether I would like to put 12 in any, like candidacy possible. So let's explore a little bit on, because let's say if I put 12 here, so I have to put 13 and make 13 from two numbers. I can choose 10 from here and I can choose 3 from here. So that's possible. Similarly, if I put 12 here, so I have to put 13. And so I can put 8 and 5. So like not that much solution that I'm like solving that I'm getting. So I will hold 12. Let's go with 11. 11 cannot come. So if you are looking at 11 cannot come here because the only sum is 11. 11 cannot come here as well, and 11 cannot come here. Sony is available because 11 is already been there. 11 cannot come to Sony. 11 cannot come to Tony because if we put 11 there, then we have to use 3 values to make an 11. Already, like if you put 11 there is no other spot for any other number. So 11 cannot be here. 11 cannot be on Sony itself because he has already gotten 11 on day 1. 11 cannot be to Moni as well because he is already getting 11 on day 2. So the only space that we have for 11 is this. Joni has to be 11. Now we are saying we have to make the value. So 11 is done. Now let's look at 10. 10 cannot come here because, like obvious logic, because he has already been have on day 2. 10 can come here because if I let's put 10 here, so I have to make 15 from two numbers, and it is possible 12 and 3 makes a 15, so 10 is definitely possible here. So 10 is definitely a possible candidate. 10 cannot come here because if I put 10 here, so the only way possible is 1, so only two numbers make it 11. And if I put 10 here, so we have to make a 7. If I put 10 here, so I have to make 7 from two numbers. So 10 is done, and I have to take 7 from two numbers. So any number from this cannot be taken. Can I make 7 from, you can say, anywhere possible that we can make 7? No, there's no possibility. The minimum sum that we can make is 3, and the maximum sum that we can go for 13. There is no possible. So 10 cannot come here as well. So which means by pure logic, we can deduce that 10 also cannot come here. So if 10 is not here, 10 is not here as well, and 10 is not here, which means 10 has to come here. That's a pure logical deduction that we have made. So 10 cannot, so 10 is also done. So 10 is also done, 11 is also done, and we have to put 12. 12 obviously, because we know that each friend takes one card and gives to another. So 12, now let's say there has to be 3 cards, there has to be 3 cards and 3 cards. So 10 and 11 are done. I want to visualize further before going on to 12. Let's say if I put 12 here, so that makes the value as 23. Can I put 2 here? No, I cannot put 2 here because 2 has already been came here. So 12 cannot be here. 12 cannot be here, and 12 cannot be here. So the only place left for 12 is this. I will make it in like increasing order sequence. That would be pretty helpful for me, 10 and 12. So that makes a 10 and 12. So 12 is already done. So 10 and 12 is 22. So 22, this value has to be a 3. So whatever there is 3, 3 is already done. So 3, 10 and 12 is done, specifically fine. Then after we have, let's look at 25. 25 and 11. So we have to make 14 from two numbers. Now 14 from two numbers, these two blocks are already used up. The only way to make 14 is 5 and 9. The only way to make 14 is 5 and 9. So this value has to be a 9 and this value has to be a 5. So this value, which means this is 5 and 9. Now let's look at the value as 11. 11 has to be formed from 3 numbers. If I put 8, then the only value is 1 and 2. And 1 and 2 cannot be possible because 2 cannot come here. Before that, I would like to see this 2. This 2 is sitting in isolation. So 2 has to come here. This 2 is done. Then we have this 6. This 6 has to go somewhere. So this 6 has to go here. That is the only way possible. Now we have to make 15 from two numbers. The only way to make 15 is 7 and 8. So this value has a 7. This value has an 8. So 8 and 7 are completed. And I will substitute the value as 1 and 4. So this value is 1 and 4. So 4 and 1 is 5. 5 and 6 is 11. I will write an increasing sequence. So this value is 1. This value is 4. And this value is 6. So this is also completed. Now on to the last day, I will not do this. I will just check what are the values that are missing, because everyone has a unique value and we will get hopefully a correct answer to every question. So let's see. So we are done with 1, 2, 3, 4, 5, 6 is remaining. 7, so 6 is remaining. 7 is done. 8 is remaining. 9 is done. 10 is done. 11 is done. 12 is remaining. So 6, 8, 12 would be onto the first part. I will just do this for the first time. I have used like highlighter. So already you can say 1 is done. 2 is remaining. 3 is done. 4 is done. 5 is done. 6 is done. 7 is remaining. 8 is done. 9 is remaining. 10, 11 and 12. So 2, 7, 9 are the 2, 7 and 9. Check the sum, that's 18. For first we also 6. This is 8 and 6 is 14. 14 and 12 is also 16. That's pretty good. Then we have on day 3. On day 4 we see 1 is done, 2 is done, 3 is remaining, 4 is done, 5 is done, 6 is done, 7 is done, 18 is 9 is done. So we have 10 and 11. So 3, 10 and 11, that makes 24. Yes, 3, 10 and 11. So this is 3, 10 and 11. And on day 4 we check, that's 1 is remaining, 2 is done, 3 is done, 4 is remaining, and 5 is remaining. So 5, 4, 9. That's that's a complete answer, and you can see that every bit is perfect right now. So that is the set, and let's look at the question itself. What is the sum of the values of all the cards with Moni on day 2? So Moni on day 2 is 20. Moni on day 2. Yes, this value is actually not 12. This value is actually 2. So Moni on day 2 is 20. Moni on day 2 is 20. If out of all the cards that were there with Tony at the end of day 3, exactly n cards were obtained by Moni at the end of day 4. So Tony day 3, Moni day 4. Tony day 3. Tony day 3 is here. Tony day 3 is here. And Moni day 4 is here. So what is the question is saying? If out of all the cards that were with Tony at end of the day 3 and n cards were obtained by Moni at the end of day 4, Tony day 3 and Moni day 4, okay, what is the value of n? So we have n cards that are being obtained by Moni and there is no value, no commonality between them, so n has to be a value of 0. Who among the following obtained the card 12 on day 4? So card 12 on day 4 was obtained by Johnny. Then what was the maximum difference between the value of any two cards out of all the cards that were there with Johnny on day 2? Johnny on day 2 is 4, 7, 10. Maximum difference between any two cards, so 10 and 4. That value has to be a 6. So this becomes a value of 6. So this was the set. I hope you like it and try it again and you will most probably got the hang of the set. So I will see you in the next lecture. See you soon.